Okay, so today we're going to talk about fronts. Now, fronts are wild. We talked about air masses yesterday and how air masses are these massive big masses of air. That's why they call air masses. Some of them are warm, some of them are cold, some of them are dry, some of them are wet. That depends on where they are on the planet. Now, when these come together, that creates what's called a front, kind of like a battlefield. On a battlefield, there's two armies facing off against each other, and where their meet is called the front. That's why they're called fronts in the weather. So a front, please get this in your notes, is where air masses meet and do not mix. It's where they meet and do not mix. These air masses generally don't tend to blend together. They tend to quarrel, just like two armies do. There are 4 different types of fronts. First one's called a cold front. We got a warm front. We've got an occluded front. And we've got a stationary front. We'll talk about each of those now. Now, the key idea for all of these is that fronts are what cause weather to change. It might be a beautiful day outside, but if you have a cold front coming in, something's about to happen. Better be aware of that. This is especially when in any situation in which you have warm air that's towards the ground level, and that's being forced up into the upper troposphere. You're likely to see some kind of precipitation. It just depends on what kind, where you are, and how cold the atmosphere is, and how cold the ground level is. But why? So we know there's water vapor everywhere in the air. Sometimes it's more humid, sometimes it's less humid. But when that warm air is shoved up, and we'll see how that happens in a second, when that's shoved up, we know this tends to create condensation. It creates clouds. Because as air rises and water vapor rises with it, higher in the atmosphere you get, the colder it gets and the less pressure there is. This creates an ideal situation for condensation. It cools down very rapidly. Then we know, eventually, gather enough precipitation, you've got rainfall, or snow, or sleet, or hail, depending on the situation. So that's why when warm air is shoved up, you get precipitation. Now, please get these in your notes. A cold front. This is when a faster cold air mass runs into a warm air mass. Okay? So this and they go in the opposite direction. The cold air slides under the warm air mass. Why does that happen? It's because cold air tends to be denser. And so the more dense something is and the colder something is, cold air tends to sink, warm air tends to rise. So that cold air slips right under the warm air mass just like a blanket. This, when that warm air gets shoved up, causes thunderstorms, tornadoes, cooler temperatures. Pretty serious stuff. Also, because it's happening in a very condensed area, that cloud tends to be pretty focused up. It's pretty serious. Now, when we're drawing on a map, we use these little blue teeth to show a cold front is moving in. Okay? And those teeth are the direction of the front. Now, the other one is called a warm front. Cold front, remember, was when the cold air moved under the warm air. A warm front is when that warm air collides with the cold air mass and it slips over it. So it's slightly different. Again, why does this happen? The cold air is denser than the warm air, and so the warm air rises above it. Now, cloud, because the warm air is spreading out over a larger area here, this is going to cause many days of precipitation, not just like this one big thunderstorm, because everything's just a little bit more spread out. It's not going to be gathering quite as much energy. We show a warm front with these little red bumps on a map. And again, those little red bumps show the direction that the front is moving. Our next one's called a stationary front. This is like on a battlefield when two armies are meeting and just neither one is giving any way. They're just stuck there. So this is when cold air and warm air meet, but neither one is really powerful enough to move the other one. They're just stuck there. This can lead to long time of precipitation because there's clouds forming up. That warm air is still rising. It's still condensing, but it's spreading out over a nice big blanket. You might get a bunch of days of drizzle or light rain, but nothing too crazy. None of those big thunderstorms, and definitely no big storms like tornadoes and that kind of thing. We mark a stationary front using a combination of the teeth and the bumps. because this shows that they are both competing in opposite directions. Now, an occluded front, well, those are fun. This one, warm air mass is caught between two cold air masses, and the thicker cold air mass moves underneath the warm one. They push it upwards, like this. So two colds coming together, one is usually colder than the other, but that warm air still rises. It's going to have to get up there somehow. And so there's this warm air mass hanging out above those cold air masses. So this is when they mix and push it upwards. This can lead to long periods of precipitation and cool temperatures. It's kind of like a stationary front because the warm air mass up there is not really moving super well. It's going to create clouds and create long-term periods of precipitation, but it's going to be colder on the ground level. So that's a stationary front, what it looks like. That's an occluded front, and what that looks like. Thanks for coming. Have a good one.